point-slope form. Point-slope form is as follows. Y minus y sub 1 equals m times x minus x sub 1, where m is the slope or the rate of change, and x sub 1 comma y sub 1 is a coordinate point on the line. How to graph from point-slope form. From point-slope form, we can find the point and the slope. The point negative 5, 2 comes from the opposite of 5 and the opposite of negative 2. You need to change the signs from the ones that you have in the equation. And then the slope, m, is the coefficient on the outside of the parentheses. First thing we're going to do is we're going to put our point, negative 5 comma 2, on our coordinate plane. And then we're going to use our slope, up 3 to the right 7, to find our next point, up 3 to the right 7, to find a third point. To finish, we connect the 3 points with a straight line with arrows on the end of our lines. Given the point negative 6, negative 8, and 4, negative 3, write the equation of the line that passes through the points in point-slope form. Find the y-intercept for the equation, slope calculation. So we're going to use the formula m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Plug in our points, negative 3 minus negative 8 over 4 minus negative 6. Got to be careful with all of our negatives, and when we simplify, we get a slope of 1/2. For point-slope form, we have all of our information. We have a point, we have a slope, so we use point-slope form. Y minus y sub 1 equals m times x minus x sub 1. The slope is 1/2, and then I'm choosing to use the coordinate point for negative 3. It doesn't matter which point you choose, you will still get the correct point-slope form. And after we simplify all of our negatives, we get y plus 3 equals 1/2 x minus 4. To find the y-intercept, we're going to rewrite the equation we have into slope-intercept form. So what that means is we need to solve for y. So I'm going to distribute the 1/2 first. Subtract 3 from both sides. So now I have y equals 1/2 x minus 5. So in y equals mx plus b, the intercept is the constant. So the y-intercept of this equation is 0, negative 5. A spring has a length of 8 centimeters when a 20-gram mass is at the end. Each additional gram stretches the spring another 0.15 centimeters. Write an equation to model the length y as a function of the mass x in slope-intercept form. Okay. The given information we have is x equals the mass in grams, y is the length in centimeters, and we have a length of 8 centimeters when the mass is 20 grams. From the given information, we have the point 20, 8. So 20 grams, length of 8 centimeters. And what we can do is use this information to determine another point. So additional gram stretches the spring 0.15 centimeters. So an additional gram would mean adding 1 to the grams, adding 0.15 to the length. So here we have 2 points. Since we have 2 points, we can find the slope. y2 minus y1 over x2 minus x1. We have a slope of 0.15. Point-slope form. I'm going to use the slope I just calculated and the point I was given, 20, 8. And if we need it in slope-intercept form, that means we need to distribute the 0.15, add 8 to both sides. Our slope-intercept is y equals 0.15x plus 5. What is the mass needed to stretch the spring to 9.45 centimeters? Since we're solving for the mass, that means we are going to plug in 9.45 centimeters into the y. Subtract 5 from both sides, divide by 0.15. 29.67 grams are needed to stretch the spring 9.45 centimeters.